All right, let's just jump right into this. We're going to tackle a concept so basic, it's kind of like questioning whether the sky is blue. We all learn about infinity, but what if we've been looking at it completely wrong this whole time? What if infinity isn't actually real?
And that is the central, provocative idea we're digging into today. The argument is that infinity isn't a number. It's not a place you can get to. It's not even a quantity. It's really just a placeholder, a word we use when we hit a wall, when our ability to count and to calculate just gives out.
So here's how we're going to unpack this whole thing. First, we'll start with the basics, the infinity we know. Then we'll get into the weird part, when numbers become symbols. From there, we'll redefine infinity as a tool for approximation. And then we'll ask the big question, does this change anything? We'll see how it's shaking math's foundations, and we'll wrap up with this cool idea of a new mathematical humility.
Okay, so let's start on some familiar ground. When you think about numbers, you probably picture a line, right?
You know the one I'm talking about. It starts at 0, and it just keeps going. 1, 2, 3, a million, a billion. You can always add one more. This picture of a number line just stretching out forever is our gut instinct for what infinity is. It's the first thing we all learn.
But this is where our whole idea for today throws a giant wrench into the works. It argues that this endless line is a useful story we tell ourselves, because at a certain point, the very concept of a number just kind of falls apart.
I mean, just try to imagine a number so ridiculously huge that our brains can't comprehend it, and even our most powerful computers can't process it. The argument is that long before we get anywhere close to infinity, we hit this strange territory where numbers just stop behaving like numbers.
So, check this out. This is the key difference. A number is something you can actually work with. You can point to it. You can tell if it's bigger or smaller than another number, and you can do math with it. You can add 1. But a big symbol, as our source material calls it, is just a placeholder. It stands for a quantity so vast we can't do any of that. You can't compare it, and adding 1 to it, the question doesn't even make sense. It's just big.
So if infinity isn't the final boss at the end of the number line, because the line itself just dissolves into these useless big symbols, then what is it good for? Well, the answer proposed here is actually super practical.
Here's the new job description for infinity. It's just a tool. It's a word we use inside a calculation. Think about calculus, for instance, to basically say, hey, keep this process going, and the longer you do, the closer to the real answer you'll get. It's not a destination. It's just the instruction for getting a good enough answer.
And this quote just nails it. Using the word infinity in this view isn't some grand statement about a boundless universe. It's a statement about us. It's us admitting, hey, we can't actually calculate this thing to the very end, so we're going to use this concept to get a workable answer. It's a moment of honesty.
Okay, this is all a really fascinating way to think. But let's get real. Does it actually matter? If infinity is just an approximation, is your phone going to stop working? Are bridges suddenly going to start collapsing?
I mean, this is the million-dollar question, right? Have we built our entire modern world on a concept that's, well, not quite real? The answer, it turns out, is maybe a little surprising.
For almost everyone, life goes on. Physicists, the source says they've always used infinity this way, as a handy approximation. So for them, no big deal. Same thing for most mathematicians who work on practical, applied problems. But there is one group that has to sit up and pay attention, and that's the foundational mathematicians, the people who study the absolute logical bedrock that all of math is built on.
Yeah, so let's talk about that last group. For them, this isn't just a quirky idea. This is, well, it's kind of an earthquake.
If you accept this new definition, some really major mind-bending ideas in higher math just get wiped off the board. You know that famous concept that there are different sizes of infinity, like some infinities are bigger than other infinities? Well, that's gone. If infinity is just our way of saying we can't go further, then you can't have different sizes of that. And the famous continuum hypothesis, this huge unsolved problem about those different infinities, is suddenly not just unprovable, it's just wrong, because the question it's asking doesn't even make sense anymore.
And that brings us to the final, and I think maybe the most beautiful point of all this. This isn't about destroying math. It's about reframing our whole relationship with it.
Look, most of science has always understood that it's approximating reality. But pure foundational math, that was supposed to be the one place we could find absolute, perfect exactness. This perspective says that, actually, even there, at the deepest levels, we've been using a tool of approximation, We just didn't realize it. It calls for, a new kind of humility.
And that's really the thought I want to leave you with. By letting go of the illusion that we can truly grasp an exact infinity and instead just embracing our own limitations, we might actually unlock a more honest and maybe even a more beautiful way of understanding the universe. What do you think?